Welcome back, Dank friends. We take a great leap forward in our Robot in 3 Days journey now by tackling what can be one of the most intimidating challenges in FIRST. Just like the convergent evolution of all life into crabs, we want to give you the tools to evolve into Swerve. Please cast off your doubts, embrace the challenge, believe in yourself, become one with the crab, and enjoy our poor folks' guide to Swerve.
Hey everyone, Garrett White here showing you a snip from our Circle City Swerve Guide budget breakdown. This table basically includes information about roughly how much it costs to make the leap to Swerve. 6721 was in a similar boat last year to make the leap, and we wanted to know how much it was going to cost. So we were always upgrading our tank drive to get the 8-wheel drop center version with wider treads, and ultimately it was costing us about $1,000 extra. So comparing that to the 2,500 total here for Swerve, honestly not too bad of a jump. Take some extra fundraising, but basically if you opt out for the drive base kit and black tote, you can get about $700 in credit back. We use the MK4i modules for a total of $1,800. Thrifty Swerve also has a good option for cheap modules. We use all Neo for turning and drive motors, Spark Max motor controllers. You need 4 encoder adapters for the turning motors, and then for the frame we use just pre-drilled 2x1 aluminum tubing. Recommend 1/8" wall thickness, and then you'll need some type of belly pan or cover material, which will depend on what you have available. All in all, you're looking around $2,500 for Swerve. Here we have our CAD design in Onshape for the Circle City Circuits robot in 3 days. We got a start on the drivetrain, so that's what you're seeing here. This design was heavily influenced by frcdesign.org, the trainings there, the example CAD, and also the multitude of Open Alliance teams from Chief Delphi. Wanted to highlight the main sketch. This is one of the most important parts of parametric modeling. Make sure that you are including your drive base dimensions and then deriving and using that later in your design. Basically, it will save you a lot of time in updates. If you need to update something major, it won't require you to update all of the parts. They'll all kind of update automatically based on your derived sketch. Also heading over to the drive base. So we have most of the components in here. All of these components are somewhat linked to that derived sketch. So like the drivetrain members, the belly pan, location of the Swerve modules, and then also the bumpers. We have some example bumpers in here. This is what we used last year for 6721. Basically, it's just plywood, foam tile, and then some foam on the outside, and then using the Andy Mark snap latches. So feel free to check that out. And then heading back to our main full robot and main sketch, I have some draft in here for the extension limits. So this can be a good start and give you an idea of where you can kind of draw things out. But one of the first things that will happen is we will put the field elements that we'll be interacting with on this plane so that we know how we can design our robot to meet the challenge. Switching over to the electrical design in our CAD, we noticed that most of the components are upside down. This is actually the plan is to keep the majority of the top surface of the design open and available for mounting subsystems to. So if we flip around to the bottom, we can see it has the majority of the components down here, like the PDP, the Robo-Rio, multiple Spark Maxes, and other ancillary stuff like radio power module, Pigeon, stuff like that. Everything that you need to power an FRC robot. On the top, we have the main breaker just in a generic location right now, but that's something you can move around with your subsystems. Just make sure you plan the thick wiring in there. And then the main battery is currently laid flat in there and is below the top surface. This can help save you some room. Another option is you can 3D print modify the top belly pan to have the battery sit vertical. Um, but basically, this gives you a lot of flexibility in what you can do on the top. Now, if you have to go through the bottom, then obviously you have to modify a whole lot of this. But this is a great start and a good platform for us when starting our robot in 3 days. Oh, hey there, not leaving yet. Just coming back to remind you to check out our Chief Delphi thread for the Onshape link. This is just a start for our CAD, and follow along over our 72-hour build to see updates and how we go about designing our robot.